Okay, now let's move on to study the most lengthiest and the toughest chapter in geometry, which is circle. And the reason for this chapter being so lengthy and tough is because whatever we have studied so far in geometry, like lines and angles, triangles, congruency of triangles, quadrilateral, parallelogram, they all will be reused in this chapter. So along with the concepts of circle, we will be using whatever we have studied so far in geometry. We are already familiar about a circle. In this video, what I'm going to do is, since circle has many components like radius, diameter, circumference, arc, so before getting into all the components individually, let's try to understand what is a circle so that we have a fair bit of idea what is a circle, and after that we would enter into explaining all the components of a circle. This diagram here, a round shaped diagram, is what we call circle. All the circles will always have a fixed point which is called the center of the circle. This is the center of the circle. I have named it as O, and the distance from this center to any of the points on the boundary of the circle is called the radius of the circle. Abbreviation for the radius is r, small r. This is called radius. Distance from this center to any of the points on the circle, whatever point you choose on the circle, distance from these points to the center will always remain same. This is the way we denote a circle. C and then O comma R. C stands for circle. This O, which is called the center here, and this is the radius of the circle. So this is the way we denote a circle. Now let's move on and study about all the different components of a circle one by one. Radius. This is the radius of the circle. It says length from center to any point on the boundary. We can call it boundary or circumference. This is what we call the boundary or the circumference of the circle. So distance from this center to any point. You take this point, or this point, or this point. The distance from center to any of the points on the boundary or circumference is called the radius of the circle, and we denote it as small r. Distance from any of the points to the center will always remain same in a circle. Whatever, we can draw millions and trillions of lines in this circle, and all those lines, if you measure the length, they will be same. Radius and radii, they are one and the same thing. Radius is the singular word, radii is the plural word. It doesn't make any difference. Circumference. As I have said, the boundary of a circle. The perimeter or boundary of the circle is called the circumference. This is called the circumference of the circle. And the length of the circumference is measured by this formula 2 pi r. Pi we already know. Pi is 3.14, and r, whatever is the length of the radius of a circle. Suppose length of the radius for this circle is say 3 centimeter. In that case, the circumference would be 3 into 3.14 into 3. This will be 6 into 3.14. You can solve it, and this measurement will give you the length of the circumference of this circle whose radius is 3 centimeter. Chord. A line joining any two points on the circle. We have millions of points on a circle. If we draw a line like this or like this, now this line or this line, they are joining any 2 points on the circle. So if we have a line which joins any 2 points on the circle, we call that line chord. Diameter. A line joining any 2 points on the circle and going through the center of the circle. We have already seen this. This is what we call chord. But suppose we have this chord which goes through the center of the circle. This chord we call the diameter. So any line which joins any 2 points of the circle and goes through the center is called the diameter. We can call diameter as the longest chord in a circle. This chord and this chord, they're also joining 2 points on the circle, but they are not going through the center. So that is why they are not called the diameter. Diameter is this line joining 2 points and going through the center of the circle. Diameter is double of the radius. Length from center to the circumference is called the radius. So this piece from here to here will be radius. This length here from this center to this point will also be radius. So the diameter would be radius plus radius or 2 into radius. That is why we say diameter is always the double of the radius. Secant. A line passes through the circle intersecting at 2 points. Look at this line here, line L, which is intersecting at 2 points, point A and point B. Since this line is going through the circle, in the secant we have seen it joins any 2 points, but it stays within the circle. Secant goes through the circle and joins any 2 points. So any line passes through the circle intersecting at 2 points is called secant. Tangent. A line that just touches the circle at 1 point only. Look at this line here. This line L is touching this circle at this point P. In case of secant, it was going through 2 points A and B. However, in case of a tangent, tangent just touches the circle at 1 point. It doesn't go inside the circle. It just touches the circle at one of the points. So this line is called tangent. Concentric circle. We have this circle here at this center, and we have drawn one more circle inside this circle with the same center. So when we have one or more circle in a bigger circle having the same center, this is the bigger circle and this is the smaller circle. This smaller circle is inside this bigger circle but with the same center. Then this smaller circle is called concentric circle. So when we have one or more circle in a bigger circle having the same center but different radius, we call them concentric circles. This is the radius for this circle here, and this is the radius for this circle here. R1 is the radius for a smaller circle, R2 is the radius for the bigger circle. I have just named them as R1 and R2. You can name them whatever you like. Arc, very important component of a circle. Piece of the circumference. We already know what is the circumference, the boundary or the perimeter of the circle, and the formula for the circumference is 2 pi r. But this gives us the length of complete perimeter. Suppose we are not interested in the complete circumference, we are talking about a piece from the circumference, this piece here, the red piece here, or this piece here, or this piece here. So any of the piece from the circumference is called the arc. This red piece, we call it arc ACB or arc AB. We write it this way, ACB or AB. We write ACB and put a hat on top of that. Or we can call it just AB, we put a hat on top of that. So if we just write AB, it doesn't mean we are talking about arc. But if we write it AB and then put a hat, then we are talking about the arc. This will be read as arc AB, not just AB. Degree measure of an arc. Okay, we just understood about the arc. Suppose this is the arc and we want to know what is the degree or what is the angle for this arc. The simple thing we do here is from both the ends of the arc we draw lines. First line from this end to the center, this is the center of the circle, and from this end connecting to the center. These two lines, obviously they would be the radius of the circle. Now these two lines will definitely make an angle here. We denote that angle as theta. Theta degree. You can call it x degree, y degree, z degree, whatever you like. I have named it as theta degree. So this is the angle for this arc ACB or arc AB. Now whatever the angle is, it is 10 degree, 15 degree, 40 degree, 100 degree, that will be the degree measure of an arc. So we write it as degree of M arc AB. M stands for the measure. So degree measure of this arc AB is theta degrees. Suppose theta is say 70 degrees. I'm just assuming this. So the degree measure of arc AB would be AB would be, if suppose it is 70 degrees, this theta is 70 degrees, this angle here is 70 degrees, would be 70 degrees. So this is the measure of this arc here. What is the measure of this arc, this big arc here? This is the smaller arc and this big arc here. This is the angle of that arc. We already know center of a circle has 360 degrees of angle. Full angle is 360 degrees. So this remaining angle would be 360 minus theta. If suppose theta is 70 degrees, so degree measure of this arc BA, which this arc would be MBA, put a hat there, 360 minus theta degree, 360 minus, since I have taken theta as 70 here, this will be 290 degrees. So this will be 290. So degree measure of this arc or any arc, or we simply say the angle of this arc AB is theta degrees, and if we know the angle, that angle will be the degree measure of that arc. Congruent arcs. This arc here, arc AB, degree measure of arc AB, and this arc here, DC. If suppose this angle here and this angle here, both are equal. Suppose this angle is say 40 degrees, just for assumption, and this is also 40 degrees. In that case, this arc and this arc will be congruent. Since angle AOB, this angle here, is equal to angle DOC, this angle here. Since they are equal, in that case, degree measure of arc AB and degree measure of arc DC, they are equal. So we can call them arc AB and arc DC, they are congruent arcs. Minor or major arc. We have two circles here. Suppose I split this circle into two semicircles like this. Now in this circle I have two semicircles, one this side and one this side. Arc of this semicircle starts from this end, goes this end. Arc for this semicircle here is from this end till this end. Look at this red arc here, which starts from this point and goes till this point. Length of this arc is obviously less than the length of this full arc, length of the arc of the semicircle. So if we have an arc which is smaller than the arc of a semicircle, we call that arc as a minor arc. In this circle here, this arc from this end till this end, from this side. Arc of a semicircle is from this end till this end. This arc is obviously bigger than this arc of a semicircle. So when we have an arc which is bigger than the arc of a semicircle, that arc is called major arc. So this is major arc, this is minor arc. In this circle, this will be minor arc and this will be major arc. Here, this will be minor arc. Minor or major segment or alternate segment. This area here, this full area from this end to this end and covered by this arc, this is minor arc. So this area will be minor segment. This area here, full area, this is the major arc. So this area covered by the major arc is called major segment. So this will be major segment and this will be minor segment. Major segment or minor segment, we can call them alternate segment as well. Sector. This is the center of the circle. From this center we draw two lines on any of the 2 points on the circumference of the circle. So this region here, this arc and these two radius of the circle, this complete region we call the sector of a circle. OABO, this piece is called the sector of the circle. This is the circle, C stands for circle, O is the center, R is the radius. This region is called the sector of the circle. Quadrant. if we cut a circle into 4 equal parts, this part here, this part here, and this part here. So all these parts individually, they are called quadrants. So this is one of the quadrants here. We have just seen the sector here. Now the difference between a sector and a quadrant is we can have only 4 quadrants into a circle because we cut the circle into 4 equal parts, and the angle of all these quadrants would be 90 degrees. However, in case of a sector, we can have as many as sectors we like. I can draw one more sector here. This is the sector here. One more sector here. This sector here. One more sector here. This sector here. However, in case of a quadrant, we have only 4 quadrants. First, second, third, fourth, and all the quadrants are equal to each other. OABO is the quadrant of the circle, this circle, and this is the quadrant. The fourth part, 1/4 of a circle, is called the quadrant. Congruent circle, these two circles here, the only condition which can make these two circles congruent is if the radius of this circle and this circle, they are equal. If R1 and R2, they are equal, if suppose this is 5 centimeter and this is also 5 centimeter, in that case these two circles will be equal. So what it says is, if suppose we have hundreds of circles and all of them have radius which is 5 centimeter, or all of them have equal radius, in that case all the circles will be congruent or equal. They will be equal circles. There won't be any difference in those circles. The only condition we have to see is the radius of both the circle same? If that is same, then circle would be congruent. Cyclic quadrilateral. We have already seen quadrilaterals into previous videos. A diagram with 4 sides is called a quadrilateral. Now look at this quadrilateral here, A, B, C, D. Now the difference in this quadrilateral and this quadrilateral is, apart from their shape and dimension, this quadrilateral ABCD, all the vertices of this quadrilateral is sitting on the periphery of a circle. However, in this quadrilateral, we don't have any circle involved. So when we have a quadrilateral where all the vertices are sitting on the perimeter of a circle, that quadrilateral is called cyclic quadrilateral. In this case, quadrilateral ABCD, A, B, C, D, all these 4 points are sitting exactly on the perimeter of the circle. So this quadrilateral ABCD is a cyclic quadrilateral. So this was in short about the terminologies involved into circles. Before getting into solving actual questions, we will look into some of the theorems and then we will start solving questions based on circle.